Hi, welcome to the exercise of lecture 6, aldol and Claisen reactions. Okay, we will start with the exercise 1, give the reaction products of the following aldol and Claisen reactions. We have this compound, this phenylmethylketone, and we add sodium hydroxide. Okay, what will happen is that this is a base, okay, and we will deprotonate the ketone. Remember that this hydrogen is slightly acidic, and what we have is that we are forming the enolate with a negative charge in this carbon. Remember that we can do another resonance structure that I will draw here, but I recommend to keep this one because it explains better the reactivity. Okay? This is the resonance structure. This is the reason why this hydrogen is acidic. But please keep in mind that this explains better the reactivity. This is reacting with another molecule of the acetone, basically. Negative charge will attack here. Why? Remember, this is a nucleophile, and here we have a carbon double bond oxygen that is highly polarized. That means that we have a density positive charge in the carbon and a density negative charge on the oxygen. That means that this position is electrophilic. This will attack here, and the double bond will go to the oxygen. And what we will have? This compound that we protonate, and we get the aldol product. Okay? Good. Then we go for the second one. Basically, they tell us that we have a Claisen condensation between and we add the base. Again, we deprotonate this position, and what we get, we generate the enolate. Okay? Again, this is a resonant form, but please keep this because it explains better the reactivity. This then will react with another molecule of the ester. Okay? Remember, addition elimination. Okay, we regenerate the double bond between the oxygen and the carbon, and the leaving group is departing, and what we get is this compound. Okay, that and the leaving group, that is the methoxide, and then remember that the methoxide takes this hydrogen that is highly acidic, and what we get is an ion that when we protonate we get the final product. all the seconds. Right? Okay, next one. The next one, we have this ketone. It's very similar to the first one. And we add sodium hydroxide. Again, we reprotonate. This time has to be this metal. Here there are not any hydrogen. We form the enolate. And this enolate is reacting with another molecule of the ketone, like we did before. And what we get okay? Then we protonate. Now what is happening is that they say that we degrade. Remember, we are in basic media. That means that another molecule of hydroxide will remove this proton, and what we will get is this compound following a E1CB, remember the lecture number 2, and now simply we form a double bond and the OH is leaving. This is the only way that an OH is leaving. And we generate the alpha beta unsaturated compound. Okay, you can get the Z or you can get the E. This is the most stable because the big group is on the opposite side of the big group here. But this is not part of this course. That means that any answer of the double bond should be correct. Okay? Okay, next one. This and we add a base. Which again, what is happening is that first step we remove this, and what we get is the anion here. This will attack another molecule the ester, addition, okay, and then elimination, and we generate this compound. Plus the methoxide. What is happening now? That this methoxide cannot remove any hydrogen here because we don't have hydrogens in the middle. Okay, we don't have any hydrogen here. We have two methyls, That means that because we cannot deprotonate this, no reaction takes place. Because basically all these equilibria, if we cannot deprotonate this final compound, basically we will come back to the initial reactants. Okay? Good. Then the question 2 we already answered it, because it's right direction mechanism for the reactions of exercise 1 that we already did. And 3 we have to explain why the following reactions didn't work. Okay, one reason why the Claisen didn't work is because we cannot deprotonate the final compound. In this case we have an aldol reaction, or looks like an aldol reaction between this compound and himself. And clearly the answer why it's not working is because we don't have any hydrogens. Here or here in the 2 alpha positions, we don't have any hydrogen. That means that we cannot form the analyte. That means that the reaction will not work. In the second example, what we have is this. Ester, and again, in this position, no hydrogens. That means that the reaction will not work. Basically, in both cases, the reaction didn't work because we don't have any hydrogen. Okay? Right? In the exercise 4, well, the first exercise is a mistake from my part because this is what we will do in lesson 7. But basically, if you are lucky, you can guess what will happen. Okay, we have this compound and we add sodium hydroxide. What is happening is that the hydroxide will remove the proton as usual, and we generate this analyte. Okay, and now this analyte can react with himself. This is option 1. Option 2, with the aldehyde that we add. Okay. I didn't do the analyte with the aldehyde because simply this aldehyde doesn't have any hydrogen in the alpha positions. Then, with who will react this analyte? Well, it's more reactive an aldehyde than a ketone. That means that this will react with the aldehyde to form this intermediate that, once protonated, gives us the final aldol. Okay, but this, we will work more of this in the lesson number 7. This has been my cat, sorry for it. He wants to learn chemistry too. Okay. Then we go for the next one. In the next one, what we have is this compound. We add a base. Well, the base, what we'll do is take one of the hydrogens. Which one? Well, this molecule is symmetric, that means any of them is okay. I will remove this. But any that you remove here or here is okay. The base will take the hydrogen, and what we have is the formation of the analyte. Now this enolate will react with another molecule of ester, but in this case we have the ester in the same molecule, in the same compound. That means that will be an intramolecular attack, addition, okay, we generate this, and then elimination, plus a methoxide, and then this methoxide will remove the proton middle, and what we'll get is that if we protonate, we will get the final compound. Okay, but remember that always at the end of the Claisen, what we need to do is reprotonate this hydrogen. If we are not able to reprotonate this hydrogen because it doesn't exist, simply the reaction will not work. Okay, and we have the final compound. Okay. Then we go for the last one. We have this. We have a base or edge normally. Again, this base will deprotonate this hydrogen, we will form the enolate. And then this enolate will react with another molecule of the ketone. Okay, one method is missing. And then finally, we protonate to get the final compound. Okay, second reaction, we have the ester, we at the base, what happens, the base will take the proton, we form the enolate. This will react with another molecule of the ester, addition, tetrahedral intermediate. Okay, tetrahedral intermediate. And now elimination, we regenerate the double bond, the leaving group is departing, and what we get is this compound plus the methoxide, and the methoxide will take the hydrogen in this position to form this compound. Whoops. That after protonation we will get the final addition product. Okay, go for the cert. We have this compound, and we add acid. What will happen? Remember that in acid media what we have is on one side we form dienol. Dienol is this compound, okay? And on the other side we protonate the aldehyde. Okay, that means that we generate this compound with a positive charge on the oxygen. Remember that this is very electrophilic, this carbon, and this is a weak nucleophile, but is enough in order to attack the carbonyl compound. Remember how it's working the arrows. This is pair of electrons of the oxygen and forming again the double bond oxygen carbon, and this pair of electrons that are forming this double bond is attacking the carbonyl group. What we will have is we will have this intermediate that, if we remove the proton of the carbonyl, we got the final compound that has to be. Okay? And they say that it's followed by heating. That means that we can try to do the elimination. If you try to do the elimination, what will happen is that we protonate the alcohol, making a very good leaving group. The leaving group is departing. What we have is the positive charge here. And now we have to do elimination, and the only proton that is in alpha is this proton. We don't have any proton here. That will be the most favorable proton because it's alpha to the carbonyl compound, and we get a conjugate compound, but cannot be because it doesn't exist any hydrogen. That means that this hydrogen is leaving, okay, and the double bond is forming, obtaining this compound. Okay? Remember that always when we do the elimination, we have to do it obtaining the conjugate compound, but in this case simply it's not possible because we don't have any hydrogen in the alpha position. This is the exception. Okay, and we go for the last one. It is a typical aldol reaction. We add base, and basically what we will do is to deprotonate the alpha position, generating this anion, and this is reacting with another molecule of the aldehyde.